In this case, these two problems, the bars are already isolated. So then you're going to create two equations. 2x minus 3 equals positive 5. And then your second equation, 2x minus 3 equals negative 5. Proceed to solve for the variable in both instances. So you have 2x equals 8. Divide by 2, x equals 4. So that's one of your answers. Do the same thing with the second equation. So you get 2x equals negative 2, divide x equals negative 1. And then you're done. All right, model 2 is, or problem number 2 is exactly the same. Since the bars are isolated, you can go ahead and create two equations. 5x minus 3 equals 9. And then 5x minus 3 equals negative 9. So then you solve for the variables, you get 5x equals 12, divide by 5, x equals 12 over 5. All right, second equation, same things, get a different answer. 5x equals negative 6, divide by 5, x equals negative 6 over 5, and then this is your second answer. All right, so in this case, the bars are already isolated, so it was a matter of creating two equations and solving both, and then you're done. 3, 4, 5, 6, all of these are exactly the same, so I'm going to skip those problems. Let's look at the next page, 26. So in this case, you have to get the bars by themselves. So you have to remove this 8 by adding. This cancels out the 8, so you get 0. So then you have absolute value, 2x minus 3 equals positive 3. So now the bars are by themselves. You would create two equations, 2x minus 3 equals 3. And then the second equation, I'm going to give myself some space, and then copy the second equation, or create it. 2x minus 3 equals negative 3. So my space is limited. I'm just going to show the final answer. It'll be positive 3 here, and then over here it would be positive 0. So for problem number 2, this is multi-steps. You have to do two things to get the bars by themselves. You have to get rid of that 4 first. So then you have 5 times absolute value, 2x minus 3 equals 5. Divide by 5. And then you get absolute value, 2x minus 3 equals 1. And now the bars are by themselves. You can create two equations. 2x minus 3 equals 1. And then 2x minus 3 equals negative 1. So then now you would solve this one like you would any normal equation. All right, the last example I'll talk about is this example on page number 27. So sometimes when you isolate the bars, if you have a negative number on the opposite side, you would just say no solution. There'll be no additional work that's required. Another example would be the result of having a positive or one solution. How would you know? So you would subtract 4 from both sides. You get 5 times absolute value, 2x minus 3 equals 0. Divide by the 5. So then let me continue over here. Absolute value, 2x minus 3 equals 0. And 0 is neither positive nor negative. So in this case, you would just write one equation. 2x minus 3 equals 0. And then you would solve. So these are special cases that you want to be aware of. If there's a negative on one side, you would say no solution. And then if it's a 0, you're going to have a solution. It'll just be 1 because you can't have like a positive or negative 0. All right, so for homework, you're going to do problems in your practice packet. I'll list it in the Teams chat. Send me a message if you have questions. We'll go over this concept as well as review all the material from this first unit in preparation for Tuesday's test.